Welcome to our live webinar from my side. Today we want to look into the topic IDS in detail. We want to clear what is IDS, how we can create an IDS file, what possibilities are there for configuring specific checking rules. I have prepared a small example for this. We will, of course, manage all our data in the management software BIMQ, and we will generate our LOIN definitions from there. But first, look at our agenda. And okay, first I will give you a short introduction about myself and of the company which I am employed. Then we will shortly clarify what IDS is. And next we will look at the theoretic workflow. How exactly do we manage our LOIN definitions in BIMQ? How we can specify checking rules here and how we can generate IDS files from BIMQ. And of course, how does the check works in a specific checking software. We will not only look at this workflow theoretically, but also practically in a prepared example. In this example, we will look closely at the LOIN definitions. What settings do we need here to configuring checking rules and what different options are there available? And of course, we want to generate an IDS file with BIMQ, our LOIN definitions, and we want to check for this example in the software Solibri model checker. About questions, please feel free. Please ask questions in the area provided for this. We will answer the questions after the end of the live webinar, and questions that cannot answered in time, we will answer later per email. Okay, shortly about myself. My name is Florian Fliegel. Since 2020, I'm employed at AEC3. My typical tasks are the classic BIM management. I'm the product owner from our data management software BIMQ. I'm supervising the field training and education. And for building smart, I manage the IFC certification process for different customers. So about AEC3, the company AEC3 has been providing BIM management services for over 15 years. We cover three specific fields. The first field is the BIM management. This includes strategic developments, um, creation of LOIN definitions, quality checks. The second field is research and development. This is about standardization, IFC certification, recommendations or expert reports for customers or research projects. And the third field is our data management platform BIMQ, in which the data can further be used in form of software templates for different authoring tools or for the output of checking rules. So what is IDS? IDS, Information Delivery Specification, is a machine-readable specification for describing alphanumeric information requirements. The data format is without these geometric specifications which are transported in the IFC format. So let's look at the current status of the development. The development starts at 2020, and now IDS is already accepted as a new building smart standard. Currently, IDS is published in the version IDS 1.0, and it has already arrived in the industry. There are currently connections to the Solibri model checker, BIM Collab Zoom, Akka as BIM viewer, or Libal, and many more. And what we see here is there are mainly connections to checking software systems. IDS describes alphanumeric information requirements. That means that it is also interesting for the use in authoring tools such as Revit or Alplan. The industry knows this fact, and so there are currently developments to establish IDS here too. Okay, if we look at the data management, how we can define and manage our alphanumeric information requirements. Then we will do this with our platform BIMQ. Here, it is possible to create LOIN definitions for specific disciplines. We can use the data created here to export to different authoring tools like Revit or Archicad, and we can use the data created here for checking rules in native formats or in the standardized IDS format. Today, we will focus on the first and the third part. So how we can manage and specify LOIN definitions and how does the checking take place into the workflow. And here, of course, we want to concentrate on the checking with IDS. The second part, how the data is transported to a specific authoring tool, such Revit or Allplan, is not part of today's live webinar. So how exactly does the workflow work now? First, we will take a look at the LOIN definitions. I have prepared a small example for this here, which I implemented with our software BIMQ. And if we look shortly at the concept of LOIN, what does it mean? The concept describes the level of detail in BIM models. This includes these geometric informations, our alphanumeric informations, and of course, all the general conditions. When is the information needed? Our milestones. Who needs this information? This is our actor or our discipline. And for what the information is needed, this is our use case, and what information is needed, this is our delivery object. Okay, in the second step of the workflow, we will look at how we can configure and specify checking rules for IDS and what are the different options here. And at the third step, we want to check with IDS. We will export an IDS file from BIMQ and we will do the checking in the Solibri model checker. For this, we will check on a real BIM model. Some of you maybe know it. It's the standard Revit architecture and structural model, what you see here. For this model, we will do an IDS check. In Solibri, there are two different options to import an IDS file, and I will show how it works. Okay, let's don't waste time anymore. Let's move on the practical part on the live demonstration. Okay, first, first our LOIN definitions. Okay, so you see here our user interface, our BIMQ user interface. We see typical information requirements for this architectural model, what we have created for this example here. There are different element types. We have spaces, external walls. We differ between external walls and internal walls. We see curtain walls, base slab. We see floor slabs, roofs, columns, stairs, windows, and we see doors. If we look closer to a specific element type, for example, to this external wall, we see a group of assigned property sets. For example, these common properties, we see a specific unique property set called identification, and we see these IFC property set concrete element general. All property sets contains to the corresponding properties. For example, common properties contains is external, the properties is external, load bearing or fire rating, and the concrete element general property set contains, for example, exposure class, straight class, or structural class. Okay, each property has his own unique unit definition here. Is external or load bearing? Here we defined in Boolean. So is external or load bearing is a true or false statement. So we defined here as an unit Boolean. Reference is an identifier, and acoustic rating, the value for acoustic rating is a string. So we defined here as an IFC label. All units that you seen here are linked to the unit definitions in the IFC schema from Building Smart. We also see the assignment to the assigned use case and milestones. So for this case, we defined the milestone coordination phase and the use cases, minimum requirements, visualization, model coordination, clash detection. Okay, by ticking this corresponding field here, um, we can exactly define what is required in the different combination of use case and milestones here. The most important column for us is the IFC mapping definition here. Um, this column, from this column, we generate our checking rules in form of native formats or in form of the standardized IDS format. Okay, you see here um, all elements, property sets, or properties had its own specific and unique IFC mapping. If we look closer to the IFC element mapping, for example, for roofs, the translation for IFC for roof is IFC roof, for stairs is IFC stair, and for window is IFC window. If you want to specify your IFC mapping, your IFC element mapping, you can use predefined types or subtypes. A good example for that is base lab. Here we defined as IFC entity mapping, it's an IFC slab, and we use further a predefined type called base lab, and here you see the other available predefined types, for example, floor, roof, landing, or base slab. When we change the IFC entity, maybe to wall, you see here are different predefined types like movable, plumping wall, or here solid wall. So um, if you want to specify and configure checking rules, the first way what you can do is the use of additional classification by properties. A good example for that is the external wall here. The external wall contains two fixed properties. For example, we have the first property is external. External wall has a true in the property external, and the second property is load bearing. Here we had also be set it to true. When we look at the internal wall contains the property is external, and here we defined the value is false. The next way to configure and specify checking rules is to define checking rules with constraints. And herefore, you have to activate the column constraints. And for this, I defined a few examples for our test workflow. The first example is for external walls. So here for external walls, I defined an enumeration list. So a good example for that is fire rating. And when we look to the constraints for fire rating to the enumeration list, we defined here the values F30, F60, and F90. These values are German fire classes, and when we look at the definition of doors, by doors we had another fire classes called T30, T60, or T90. Another good example for defining enumeration lists is the property material. For material, here we say, okay, we have valid materials for the external wall, and these valid materials are the material brickwork and concrete, reinforced concrete. When we look at the doors, here we had defined another materials. We defined aluminium wood, steel or wood. So this is the valued materials for doors. Okay, the next rule set configuration is about the property thermal transmittance. For thermal transmittance, we defined a range. When we look into it, for this property, we defined the range should greater than 0 and should smaller than 9.0 Watt per square meter Kelvin. To defining ranges is a good opportunity to check your IFC model about consistency. So the next specific checking rule, what we defined it for the element type base lab. When we look into the base lab, here we make a specific definitions for the property is external. We know is external is the unit type Boolean, so there is a true-false statement. And for base lab, we know the property is external should also be true. So we set true as a fixed value here for the property is external by the element type base labs. So the next checking rule, what we are configured and what we want to check is for the element types spaces. So we open spaces and we look not to the common properties, we look to ID identification. And here we want to check the room numbers or the space numbers. And what we see here in our constraints column is a more complex term. Here it is possible that we can define patterns, and here are two options. We can define regular expressions, that's advanced options, and we can define the substring, that's the simple option. So we want to use the advanced option, the regular expressions, and what will we do here exactly? We want to check room numbers against a room schema. So in this regular expressions, we say every room number has started with the letter G, followed by a digit zero, and then followed by another digit, and the number of the digit goes from 0 to 3 and describes the number of the building story, followed by the letter R for rooms, and now a three-digit number 0 to 9, 0 to 9, 0 to 9 ends with a dollar sign, and the dollar sign marks the end of the regular expression. So this is our room schema, what we want to check by the IDS checking, and we will see how Solibri deal with this regular expressions. Okay, the next and the last configuration of specific checking rules is for base quantities for the element types room. Here we want to check another range for the net floor area. It's a base quantity. And here we want to check is the net floor area greater equal 5.5 square meter. So this is our requirement, and this is what we want to check. Okay, so now we want to generate an IDS file from this LOIN definitions, and we want to check if the data that we are defined here in BIMQ also match with the data in our IFC model. What we want to export in the project phase 5 in the coordination phase, and the use case minimum requirements for this combination from use case and milestones. We want to generate an IDS file and then want to check the IDS file in the Solibri model checker. So generating an IDS file in BIMQ is quite easy. We go to documentation, checking rules, and here we can choose our checking format. We can choose between native formats for Solibri, DSite, or BIMCollab, or we can use our standardized IDS format. And this is what we take. We take IDS in the current version 1.0. The next is we have to choose our interface format. We want to check in IFC4. We edit our actor is architect, and our discipline model is the architectural model. And now we choose our milestone. We take our coordination phase, and our use case is the minimum requirements. And now we can generate an IDS file. Okay, I will save the IDS file. And now we look into the Solibri model checker into our IFC model, what we want to check. Okay, so we see here these standard Revit architectural or structural model. And in Solibri, there are two different ways to import an IDS file. The first way to import an IDS file is we go to File and then to Rule Set Manager. And first, we have to create a new rule set. Then we see here we must choose the correct Solibri common rules, and the common rule for that is the IDS validation rule here, and we take this IDS validation rule. So you see the IDS validation rule here is in a pre-release. That means it's not finished yet. So Solibri is working on this rule and it's not finalized yet. So next we selected the IDS file, and then we opened the IDS file. Okay, now you see additional informations about this IDS file. So you see the required element types with the required properties. You see classification by property when you use it. And you see furthermore specified checking rules. For example, here we defined the room number as a constraint, and here is the constraints pattern, what we want to check. Okay, that's the first option to import an IFC file in the Solibri model checker. And the second option I will show you. So I delete this checking rule. I go back to my model, and now we go to the menu checking. And now here we have deselected or remove the old rule set. And now the second option to import an IDS file is quite easy. We can use here an drag and drop function. So you drag your IDS file and drop it here in this area, and now you see Solibri organize this IDS checking rules, organize it to the specific element types like spaces, external walls, internal walls. So we define it in BIMQ. Okay, the next step is we want to check this IFC model against the IDS checking rules. So we go here to check model, and now you see we generate some issues here. So the first issue contains to the element spaces. So look at this element tools, this element type, and we see two different issues. The first issue is about the net floor area. So we remember we defined a specific checking rule for the net floor area. We say the net floor area should greater equal 5.5 square meter. And when we look into this room, and we go to the base quantities. Here are the base quantities, and we look to the net floor area. The net floor area is smaller than 5.5 square meters, so Solibri marked it as an issue complete correctly. The next issue is about the space numbers, the room numbers, what we are defined. We want to check against a room schema, and we see here some rooms are past the test and some room or the most of the rooms failed the test. When we look at our components view, we can look at the past elements. So we go here to past elements and we see, okay, these elements, these rooms or spaces has passed the test. We see here the room number numeration. It starts with the letter G, followed by the digit 0. Then another digit describes the building story. Another letter R for room, and a 3-digit number 302 for our room number. So all these rooms passed our test. And when we look at the rooms or the spaces who failed the test, we see here, we see only a 3-digit room numeration. So these rooms here failed the test, and this is a complete correct issue here. When we look at the external walls, we had another issue here for thermal transmittance. Okay, we look at thermal transmittance and we remember, okay, for thermal transmittance, we defined another range. We say the value, the value for external worlds for the property thermal transmittance should smaller than 9.0 watt per square meter Kelvin. And when we look to this wall, to the properties, to the general properties, we see the thermal transmittance here has the value 9.1, so it's higher than 9.0. So it's also a correct issue. Look at curtain walls. So for curtain walls, for these 3 elements, for these 3 curtain wall elements, the properties is extended warranty on manufacturer are missing. When we look at the components view, we had many curtain walls who passed the test. Here we had 31 curtain walls who had passed the test, and these 3 curtain walls had the missing properties is extended warranty and manufacturing. The same problem is occurs the roofs. We see this small roofs here, and on this small roofs the properties is external, load bearing, material, name, and reference is missing. We had one passed roof. It's our main roof, and the main roof had passed the test, and the other roofs had failed the test. So here we had to adjust these properties here. Okay, look at another issue, and the next issue concerns doors, single doors and double doors. We look at the single doors first, and here there are problems with the property fire rating, and we look at the issue description, and here we find out that a false value is set. Here by these single doors, the value for fire rating is F90, but our enumeration list only accepted the values T30, T60, and T90. So there are false fire classes here defined for these values. And when we look to another issue, thermal transmittance, okay, it seems that thermal transmittance is missing by these doors. When we look to the double doors, we see, okay, there are some issues here. Another properties they are missing. so CMIT. Okay, but we see um, the issue here is not clearly. When we go to single doors, you see also double doors, and when we go to double doors, you see only single doors. So here everything is not correct here. So what can we do? First, we go to our checking rules in BIMQ, and we will look at our checking rules. Maybe the issue concerns there. And when we look to our definitions for single doors and double doors, we see they have the same IFC mapping. The mapping is IFC door with the predefined type door. So Solibri cannot differ between this specific two element types. So we have to clarify the IFC mapping here. So what can we do? We go back to the Solibri model checker, and now we want to look at a single door, and a good property to identify a specific element is the property reference. Here for reference, the value single door is signed, and when we look to double doors and we look at the reference property, here is the value double door signed. Okay, what can we do? We can specify our checking rules in BIMQ. So, and that is what we want to do. So we go to single doors, we take the function additional classification by properties, and now we want to use our property reference with the value single door, and for double doors we want to use the same property reference with the value double door. Okay, now I have specified my checking rules. What I have to do is to export another IDS file. So we go to checking rules. We choose the IDS format. We choose it in IFC4. We choose coordination view in minimum requirements, and we exported a new IDS file. Save this IDS file, and now we want to check again in the Solibri model checker. So we had to remove the old IDS checking file and now import the new IDS checking file. And now when we do a check, we see, okay, we had only one issue here on single doors. And when we look into this issue, it's the same issue with the fire rating here. The false value F90 is added by these doors here, and we had a fixed enumeration list for their valid values T30, T60, and T90, and these are the correct values.